I'm Dimitri. I'm going to present this morning. Sorry for the delay. Apparently my brain calendar put 9:30 on the calendar, so I was aiming for 9:30. I guess we're going to use the whole hour for now. Hope you enjoyed your time here. It's the last day. We have a few more days from the beach and enjoy. So I come from CIRIC, which stands for Cyprus Research and Innovation Center. It's a private company, privately owned. We're part of NCASE project, one of the enterprise partners. So we're working with academia in order to do some research and try to get the tools to improve our. I'm going to go very quickly a bit through about who we are, as you know, and where I'm coming from. CIRIC was founded in 2014. It's a very young company, but with a very good European project record. We have projects, around 35 funded projects, R&D mainly, in several divisions, over 40 million euros of worth. Has several divisions. I'm going to go through them later. Our main goal is to provide the research and innovation services, either ours for research purposes or for new products, and help developing and prototyping of new products. We aim to become a leading research and innovation center in the Eastern Mediterranean, at least, and we have several new company startups under our pad. We are also an authorized business innovation center for the first authorized business innovation center in Cyprus. We have an incubator for startups where we try to help new ideas come to life. This somehow the team behind the scenes. You've already seen George for the whole week. I am and George, we are coming from the IT and software division. We have 4 main divisions. We work on engineering, design, and prototyping, IT and software solutions. We have a consulting entrepreneurship services division where we provide all the support for startups, either this is business and legal or technical support. And we have an electronics and telecommunication division also for networking. I'm not going to go through every division. I'm going to go only from where we come from. We have the IT and software solution divisions. We are currently 5 people. It's a prerequisite for anyone to join the division to have a beard. So that's why you see us like that. And we are responsible for the development of the software on the European projects. We have some own projects regarding Internet of Things, data analytics, working with local companies in order to put their stuff into the cloud. We have a project from vineyards, monitoring vineyards and using the data to improve the wine. If we get to test the wine, that's a better outcome. Pandelis is our manager. We have our newest addition is Loizos, who is also part of the NCASE project. He will be joining Roma di Tre on November. Rafael is already in Aristotle University doing a year for NCASE. George here and me. For any contacts, this is going to be on the slides. You can find us online. Have some offices in Greece also. We are based in Nicosia. But we're trying to be as international as possible. So, besides this, who am I? I guess why I'm here to I was born and raised here in Cyprus, in Nicosia actually. I finished high school, moved into Greece and University of Crete for a bachelor degree in computer science, where I stayed for several more years to finish a master's and a PhD degree, all in computer science, working mainly on network monitoring and online services, monitoring analysis, file sharing, and information sharing services. Part of that, I was an intern for 5 months in Telefonica in Barcelona, working again in cloud infrastructure services and some analysis of social network data. Finishing my PhD in 2011, I moved to Georgia Tech in Atlanta, Georgia for a postdoc. I was working again in 2 fields, again computer networking and social networking analysis, and moving to the network science view of things, where you can view whatever you are analyzing as a network and see how the connections form and break and what their value is. I haven't said whatever questions you have. I'm still talking about myself, but stop me whatever you don't understand what I'm saying. So after a couple of years in the US, I moved back to Cyprus. I don't know why, but I joined the University of Cyprus for a postdoc, had a teaching experience for several classes, social network analytics and distributed systems in several local universities, the Open University of Cyprus, European University, University of Cyprus. And in November, I joined CyRIC as a senior software developer, trying to move the research experience into something more touchable, services that go out. My main interests are in the social computing area, mainly with integrating the social media, when it comes to content, what people write, how they express, with the underlying social network, so the connections and how one affects the other, how the connections affect the content, how the content goes into the network, and how the content affects the connections, either creation of new connections or breakage of connections. And trying to actually get as much as more information from social network and social media possible. So today what we're going to talk about is a bit of a part of this knowledge extractions from online social networks, and we're going to go on user location identification and how this can be applied. What we do, the main picture here is we get information for several social networks, we combine this information if we can, pre-process, analyze the user-generated content in these cases, and this leads us to identify the user key location. I'm going to talk about key location. I'm going to show why. But talking here for the user home and the user workplace, 2 key locations that the user spends usually most of the time. And after that, we try to put this information to several applications to see how the user moves around, what impact does that have, how this impacts its own network, his connections with other users, and how his movement may affect his mood, his sentiment, as is expressed from the social media, social network posts. So, location is important. Several fields, several studies are trying to identify the locations, either to better understand how users move. This comes out of too much information. Social networks are increasing the information it can give us, and we can get a better sense from what's happening instead of getting an annual census or a 10-year census. So with all this information, we're moving to social networks and what we can get from there. In this case, how we can get the location of a user, and the location can be used in several fields besides understanding how the users move. This can help into getting decisions for changes in the city infrastructure. Those can be used for field architecture and change the roads, pedestrian roads, useful information from them. What the influence of the location has in the social structure, are people connected to spatially close other users or further? Is it actually a global network or is it a localized interconnected network? We can better design the social network architecture, identify transport patterns, and challenges, of course, for user privacy. If I can't see whatever you are in every single moment, that's becoming somewhat scary. And we also show how it can be used in combination with open data information that's out there and how this can give us more information. The problem is that only a small number of users share such information. That's good for them, that's bad for us if we want to do analysis. And mainly this information they give is in a higher level. It's our country level. I reside in Cyprus, state level of the state of Nicosia, or city level. I'm living in Nicosia. And most of the studies looking at this were trying to infer actually the city level. And we are trying to do something better here and try to identify the location of the user in a postcode level. That means around 2 to 3 kilometers of radius around the user location. So what we're asking here is whether it's possible to identify the user's home and workplace location by just observing the locations and time that the user tweets. We're using mainly Twitter here and trying to get information for each tweet about the time he tweeted and the location he tweeted, and trying to put together a method that shows that the user's home location and the user's work location can be identified. And we named these two places as key locations, and as I said, we tried to identify that as a postcode level. We get into the information we use are geotagged Twitter data. That means tweets that actually have longitude and latitude information on their post. And this what we work. We got data from 3 distinct geographical regions. I'm going to say some more information later. And what we saw related to the state of the art at that time. We kind of performed that studies, both granularity and accuracy. And we also compare and validate the results with some open data, Census, and had to see how close we are and if this method can be used to have a daily, monthly census just coming, population census in this case, just coming out of Twitter information. So the data sets. We have always the harder part of any study to collect the data set. We work with 2 different data sets, one for home location identification and one for workplace location. For home location, we are using only Twitter data, geotagged tweets coming from users from several areas. For workplace location, we had to go one step further and actually relate the information coming from Twitter with information for the same user coming from LinkedIn. I'm going to get into details in a while. For the home data, home location, we get the Twitter stream for 3 different areas. If you go to Twitter and put a box, geographical box, you can get only the tweets coming from that area. So we went for the whole country of Netherlands, the city of London, in the UK and the geographical area of Los Angeles County in the US. So we have 3 different data sets. We go look at the stream, we collect the number of users that actually tweeted from that area, and then we use these users as seeders in order to get more users. We go from each user we have collected from the stream to go to his friends, and mostly reciprocal relationships, close relationships between the users, and collect also their information. And we collect here the tweets they posted and their profile information. This resulted into big data. We had about 1 million users, more than 1.5 billion tweets. And in our case, the geotag tweets were about 6%, and that was good for us because most of the studies showed up to that time geotag tweets around 3 to 4%. So we had a lot of information to work with. Also, we collect the postcodes from all the areas we said. This open data went to the sites of country of Lebanon, the public sites. We collect all the postcode areas, same from the Los Angeles and London, and we actually placed our users, ground root users, into that areas. The average area, as you can see, is around 2.5 kilometers, the average radius of each postcode. So with this method, we can say how the user resides into a 2.5 million radius, this is his location. So for for ground truth here, we use users who actually reported their exact location in longitude and latitude in their Twitter profile. So from all these users, when we search who reports his exact home location for inter Twitter profile. So we use this user as a ground truth in order to evaluate our method. So the harder part for the data set collection was to get the workplace location. And the problem was that users don't post duplicate information. They post their home location with no feed for posting their workplace location. So there's no such thing with Twitter, but there's another network which is completely designated for that thing. It's LinkedIn. You have professional profile, something like your CV, where you work now. You mentioned the company, usually the company where it resides, and usually again in a city level. I'm working in Telefonica Spain, Barcelona. That's probably the statement that's you're going to find. So how do we go from Twitter to combine data with LinkedIn? Luckily for us, at the time, I think after that closed, not our fault, but there was a social site named FriendsFeed where users could go and aggregate their social networking profiles. You could go and put your information and login information for Twitter, LinkedIn, Facebook, and that site actually created a unified page to show the information. So we went to FriendFeed and got its public stream and identified users that have accounts on both networks, both in Twitter and LinkedIn, and also had geotagged information. And we resulted with around 3,000 users that actually had the information. This is not area specific, this is a worldwide data set. The other problem we had to solve is that the company reported, like someone mentioned, IBM Research. If we search for that on Google Maps, we find the headquarters of the company, or in Google in the US. So we had to limit it down and pre-process the data in order to combine the home location and where the user probably is. His work location is a bit difficult for the one to reside in Netherlands and his office to be in the US. So we get the geolocation for the workplace location for each user, combining this information. What resulted here, we had a small number of users, around a bit more than 300 with 1 million tweets a bit, and most of them came from the United States, Great Britain, Italy, Spain, and most were working on the information internet companies. So this is a bit analysis of our data set for workplace location. This is about the data set collection. Any questions, anything you'd like to clarify? So this is the data we have, and now we're trying to find a way to identify the user's key location. And we came up with a method. It's called time frame clustering method, and what it's based on is that users usually have a routine. You wake up, you go to work, you spend a significant amount of time, some hours over there, then you have some after work activities, either go for a drink, sports, you can a grocery store, and then you reside again at home for a period from the late at night or early at night up to the next morning. And this is usually what happens during a weekday. So what we say, okay, what if we split the day of a user into different time frames and try to identify the home location for one time frame and the workplace location for a different time frame. And in order to do that, we actually plot the tweet frequency for all users is average over the hours of the day. This one plot for each different day. And what we've seen here is that we have a point that tweet activity goes down and stays down up to early in the morning around 8 o'clock, where it starts becoming active again. And we said, okay, we can use this rest area time frame, as we call it, to check whether at that point the user is in a single location and whether that location is home. And use this active area to identify the workplace. This is the time usually someone is at his work, and keep some time that after work for leisure activities or whatever the user wants to do. So here we identify what the time frames will be. So that's one of our thoughts. The hypothesis had to say that actually the user is tweeting mostly from a single location during that time frames. So what we check next is for the users we had the actual information is to get the distribution of tweets that actually come from the home location. And this is what it shows for each hour of the day, what percentage of tweets come from the home user stated home location. And what we can see is that most, in the rest time frame, most of the tweets come from the home location of the user. Similarly, for the work location, most of the tweets come from the work location during this time frame from 8 o'clock to 1900 hours. So we're thinking we can verify this hypothesis that usually the user during weekdays, it's only for weekdays, we don't go for weekends, most of his tweets will either come from his home location at late night and early morning, and come from his work location at the morning and the afternoon. So with this information, we're verifying the hypothesis we have, and we're proceeding to make a method actually to identify these home locations. Another thing we saw is that what's the number of different locations that the user tweets from during the active and the leisure time frame. So what we expect here is that, okay, I'm at work, I've done a significant time, I might go out for lunch, I might do something, I might go out for some work activities. But is it mostly from a single location that I'm tweeting? And this line here, the purple line, that's what it shows that usually tweets that come from that time frame are come mostly from one or two locations. On the other side, during leisure time frame, where after 7 p.m., after 7 p.m. we have a bigger number of locations that users might go to, different areas for drinks, for visiting friends, or whatever. So it's clearly that at that point we have a great variety of tweeting locations. So what's our method here? We go actually and measure the different locations the user tweets from during his day. And for the home location, we check on the rest and leisure time frames, and we give a different weight for each home tweet and a different weight for each leisure tweet. And that's because what we saw the previous slides here actually, that most of the tweets in this time frame, both leisure and rest, come from the home area. So we give a different weight for that tweets coming, and for the work location we measure actually the tweets coming from that time frame and get the location that most of the tweets come and designate as a home work location, workplace location for the user. For the weights, we check all our data sets and seen that most of them are identically around 74 to 75% of the tweets come from the home location during that area. So we give a weight of 0.74 around to the rest time tweets, and a weight of 0.36 to the leisure time tweets. Any questions up to now? No. So it's basically the methods that we need to evaluate and show that okay, we're doing this well. And the scenario is that we want to identify the user home and workplace location. The postcode granularity, we have ground truth users who reported their exact location, or the postcode in the Twitter profile. And we also have the combined data set linked into the data set for workplace location. And we compare this with approaches that actually use different methods to identify the user's home location. Our metrics here is actually to identify the accuracy. Accuracy measures the percentage of correctly identified user's key location. Also check the accuracy within a radius. That's saying how far, even if we didn't exactly find the same postcode the user, how far away did we go? Did we find the next postcode, or did we find them in the next city? And these are methods that are used into other papers as well. And also we measure the average error distance to get the distance from what we identified and what the correct location of the user was. So the comparison method comes from two papers, one from Gorkiev, Nulas, and Mascola, where they actually just decided that the home location of the user is the most popular location he tweets from, just looking at all the tweets. And from paper from Ria and Moon, where they used that median clustering, actually getting all the location and getting the median geographic location of the user to report as the home location of the user. They claim that they were correct in 10 kilometer accuracy. And the time frame clustering is a method that I just presented here. So for the ground truth data set, is the result we got. For the overall accuracy, we have up to 80% accuracy. It's higher than any of the other methods. And in some cases, some data sets, we go up to around 50% higher, 0.50 higher than the other methods can provide. And we go significantly higher than random. In this case, it's either saying that the user randomly decides on that. And also for the average error distance, we have mostly at 2.7 kilometers away from the user location. And that's, as we saw for the postcode data, is we just identify the user to be in the next postcode area. That might happen, it might be in the edge of one area, so you can identify that is in the next area. So accuracy under radius here we have the distance and the x-axis and the cumulative ratio of correctly identified users on the y-axis. And what we see here up to 70% we have zero radius that we identify in the exact postcode, and we get very good accuracy up to 90% only with 5 kilometer ratios. On the other side, the other methods can need about more than 7 to 8 kilometers to identify the same accuracy of the user. So another question that may come is, okay, how many information do you need to get that? How many tweets does a user with geotag information does a user has to post in order for us to get that information? And it seems like this for the 3 different data sets, the number of tweets and how the performance of the algorithm increases, and it seems like we can get more than 80% of our accuracy with only 10 tweets, 10 tweets or less. Also is not that much information. It shows that it doesn't need to be all the tweets of the user to be geotagged. Only if some of them are for a small period of time, you can get his actual home location from that. Also, for the workplace location, have the same analysis. Remember, this data set is more global. It doesn't come with different geographical areas. Again, we can identify more than 60% of the users and the exact postcode of their work location, and up to 76% with 5K radius. So again, we are better than the other methods. We give a more precise key location identification in that. So to go and further check what our data can say, we went to LA County webpage. We got the population census data that actually happened with around every 10 years, people knocking on doors, writing down how many people live here, what their home location, what's their work location, and so on. And we went and compared that census for each postcode with what percentage we could get from a treated data. And these heat maps here show the area, and the lighter the color is actually, the smaller the difference from the actual census of that area. And 84% of the areas actually we predicted with a very small difference from the actual census of the population. That's percentage of the population that we identified to reside in that area. And similarly for the workplace location, we had again same success. We could identify 85% of the workplace locations from the users with 0.005 difference from the actual census. And this was a good time for us because we can say, okay, we can use this method to get enough close census of population in periods of less than 10 years, in 6 months, in 1 year, and get a feeling of what's happening in the city. Maybe you see people moving around or changing jobs, to identify the reasons and see what's happening. So, in an overall, our target here was to detect the home location and the work location of the user. We give a radius of less than 10 kilometers in almost all the cases. Better than both methods that actually used to provide this information. And these methods were actually used to identify the location and check for something else. So they are trying to use their data set as ground truth. So our suggestion is that this method we are presenting can be used to have a better ground truth and understand better the information we have. For the workplace location, again, we have 80% identification of the user workplace, and with the first study that actually built and used such a data set combined from different social networks and actually identify the work location of the user. Again, any questions you may have? This is the method, evaluation. Okay, what can we do with that? I guess you can think of several stuff you can use this information for. What we tried to say, not in very deep analysis, but we tried 3 different use cases. One is to, okay, how the mobility patterns of the users, how the users move into the city, into the country, are affected by their home and their work location, how the echo network of a user is formed based on his actual location and the location of his peers, and how the home and work location and the leisure location affect the user sentiment. I'm going to go through details for each of these over here. Okay, starting with mobility patterns. What we want to see here is, okay, we have the home location, the work location of the user, so how the user moves after that during the weekends, how he moves around the city, how far is one location from the other, and what that can say either for the country or for the city he lives or for the user itself. And what we've seen here is actually for the 3 different data sets. Sorry for the not very good quality picture, I didn't have any others here. We have the home to work distance, the home to leisure distance during weekdays, the home to leisure distance during weekends, and the work to leisure distance the user moves during weekdays. So, for example, for the Netherlands, we can see that the home work distance is mostly about 50% around is less than 10 kilometers. As people live close by to their work, but actually differs from the other 2 cases where that goes up to 70, almost 80% of the people actually live closer to their work. Sorry. In all cases, we can see that in the weekends, home to leisure distance increases, go further, go to different places outside of the city. Whether on weekdays, the leisure points are closer either to the work location or the home location. Okay, after work brings, you go home and go somewhere close for leisure activities, either a park, either a coffee shop, or whatever. And as a summary, what we've seen here is more than 65% of Dutch users actually live far away, further away, 10 kilometers away from their work location. Have an explanation for that in a moment. On the other case, Londoners and living closer to the workplace. And what's interesting, what happens in Netherlands, you have an allowance, a travel allowance when you live 10 kilometers or more further for your job. So you have free tickets for the buses and trains. You have, I'm not sure about, you have in-pocket money. Companies provided, and I think it's a government fair thing that the government put it here in order for the suburban areas to grow up, or am I? Okay, so that explains what we see here. We see that they choose to stay further, maybe in better house, because they don't have the expenses of moving around and going to work. So what we check further is how far the distances the users travel, how far they travel from their home. And this is the probability actually of the geotag tweets from their home. It follows we can see the distribution that most of their tweets come closer to their home, but we have a number of tweets that come from further location up to 1,000 and 10,000 kilometers, moving to going abroad for travel, for work, or for leisure. And what was interesting here that our figure is pretty much similar with a study that came up from analyzing the mobile network, the calls people made or the text messages from the check-ins from different locations during movement. And this comes from mobile data phone. And our data are pretty close. The slope, we can also see the slope here in 100 kilometers. Number of people commuting more than 100 kilometers further. And we can actually use the same information from the social network to give us information that comes from mobile network that usually we don't have access to. That was a study for Kuala and Brinkite. Let's see here. Any questions on this case? Any ideas? No? So the next thing we want to look up is how does the ego network of the user actually is affected by the location of the user. Everyone knows what we mean by the term ego network? Sorry, everyone knows what we mean with the ego network, the term? It actually characterizes the connections of me with all my acquaintances, and depending on how you define it, actually you can include the connection of all my acquaintances or not. You can have only the connections of me, or include also the connections of the people that are connected with me. So we wanted to see how what the distance of the user's followers are from the user's home location, and also examine how the distance differs in strong relationships, as we define strong relationships in cases we have a reciprocal relation. It's I follow some user and that user follows me back. that usually denotes a tighter connection between the two users. Either you know the user personally, you have a friendship with them. And we also again used as a further step demographic data from the LA County to examine how similar two users are connected are and how similar their locations, home locations are. So on one part, this is for the three dataset, the fractions of the user followers that reside in the same home location as the user. This is in relation to the number of user followers. That comes actually for less than 500 up to 1,000 and so on and so forth. And we actually see that the actual number of users that are close to that is pretty much similar. A close number of friends or followers of the user are residing in the same location, and this can be thought of the number of actual users that I have interaction, I can have actual interaction with. And that doesn't change the actual number, even if we have 5,000 followers or 500 followers. And we can say that, again, we agree with the results of another study came from IBM for the online profile of enterprise users that came, I think, again from LinkedIn. And it showed this similar thing that users have a number of their friends, a big number of their friends close to their home and work locations, even in online social networks. So we view this in a different way for the three data set. What's the fraction of the users, of the user followers in relation to the distance of that follower. And again, we see that most of the users are in a close area of up to 20 to 30 kilometers distance from the user concern. This was something that unexplained. About 50% of the users in the Netherlands had a big number of followers coming from bigger than 100 kilometers area. That might be professional relationships in other areas, so working in IBM Netherlands, have connections with IBM in the US, or on the part that people are living close by more than 100 kilometers, but in other cities they have different network there, and a different network in the city they come from and the city they work to. Again, most of the followers are in the close proximity, 90% in the LA case, less than 50 kilometers from the user. And the comment about the Netherlands, where we see some differences there, different connections, different distances. So, okay, this is for the general user-follower population, but what happens with the closer relationships of the user? And how we identify that in Twitter by reciprocal relationship. If we have two users, each one follows each other, we can say that's reciprocal relationship, and it's often considered in social network analysis as a stronger relationship than the single direction relationship. So we run the same thing, the distance of the user followers, only for followers that actually are reciprocal. And again, we see similar case. Most of the user's close friends are in less than 30 to 40 kilometers from the home location of the user. Again, the same thing for the Netherlands. We have a number of users, close friends, but in distances more than 100 kilometers. And this 12 side strengthens that the notion that the user, that the reciprocal relationships of the user show a real-world relationship. We have a connection outside of the social network. We work together with our friends. So to further check that, to go another step further, we combine this information we have with open data information, again for the LA County. And what we are trying to see here is that, okay, we find strong relationships between different postcodes. How are those postcodes related with each other? And we check this into economic status. We can get the average income salary of a postcode that shows what's the general status of that, the people residing, that's living in that postcode is in economic terms, and we compare the relationships based on the distance and the economic status, and how far they differ from the economic status. And what we see here is actually what's the difference in the annual salary for the users, and what's the fraction of reciprocal relationships. So how many of the close relationships live into postcodes that are similar economical status of the user. And what we're seeing here again is that most of the around 50% of some of these come up to 20K to 30K difference in salary. And we're speaking for LA County. I don't know exactly recall the average salary, but in the order of 90 to 100,000. So that doesn't give any big class difference. Even in 5K difference, we're talking about the same class, economical class of people that are actually friends with. Covered that, and as a final use case, okay, we went very, very abstract. How does the home and work location and leisure locations actually affect the sentiment? And what we did here is actually we use sentiment as a commonly used measure to see the emotional status of the user, whether he's positive to something or negative to something, based on what language he uses in this post. And we combine this information with location information to show how different key locations affect the sentiment of the user. And for the sentiment, we use the natural language processing toolkit from Python to get a sentiment for English tweets. We divided the tweets into 3 categories: home, work, and leisure. Excuse me. And for each of the days, we calculate the average sentiment of all the users that actually correspond to that category. And that goes for about 2 years, the tweets we have, about for 2 years from 2013 to 2015. And this plot shows actually the sentiment here for the dates. And the average is always positive in our case. We don't have negative. That doesn't mean that's very positive. The numbers are close to 0. That might be considered as actually neutral. But what we observe here is that leisure locations are significantly more positive than home locations and work locations, and home locations are somehow more positive than work locations. So it seems like nobody feels good at his work in relationship to other locations. And the tweets that come from home are a bit more positive. Tweets that come from leisure locations where the people go out, spend their time with their family, friends, are significantly more positive in all cases, and we also can see cases where we have peaks in some cases, something happened. We didn't go into what exactly happened that day, but these are consistent either the user is at home, at work, or in some other location. So this is the whole presentation I had to do. This work comes from 2 papers in Astronom 2015 and Social Network Analysis and Mining Journal in 2016. Is work done with colleagues in the University of Cyprus, where I was a postdoc there, and what we try to do further here is to try and correlate these mobility patterns, this sentiment, and this functionality of the eco network with the information that comes from sensing the city. Would we have either the simplest of how the weather changes, the movements, the sentiment of the user, and even more information from Internet of Things sensors that are coming, and to try to also give some context into the tweets of the user, depending on their location, whether an accident was at some point or something infrastructurally happen, how the users react, and try to get a warning system if we can, to give information to public services for fixing stuff. Of course, there's a big issue here. What are the security and privacy implications of this information that users post out? We didn't go into detail into there, but that's always an open field of study, and whoever thinks that can work on that can gladly to talk with you. So thank you very much. This was any questions? Anything? It can be done in any further. We had some collaboration with IBM Netherlands. For example, at the point that they bought weather.com, I think IBM bought weather.com. We're trying to combine the data, actually the weather data, with the movements of of the people, and how they, even if they're getting the bus more or are driving more, cycling more, or whatever. But in our part, we are trying to put some sensors in Cyprus, Internet of Things sensors.
So we are trying to build a network of sensors.
Yeah, and to also combine that information. Anything else? Okay, I guess thank you very much. Theo is going to tell you what the